Góðan daginn allir. Nú með hann Roberth Strand sem fer yfir infrastructure as a code og Terraform í Azure. Þannig að sjáum hvernig þetta fer og bara bjóða honum velkomin. Welcome Robert. Thank you for giving us the time to go through this. I'll give you the torch, so go ahead.
All right, thank you. What I presume you said is that we're going to take a look at infrastructure as code today, which will be surrounded, where we're going to be talking about Terraform and Azure specifically. So first, I'll just mention a little bit about me. So my name is Roberth Strand. I work as cloud architect for Crayon AS, so Crayon in Norway. I do a lot of DevOps and GitOps things, mainly do cloud native things, Kubernetes, and all those kind of silly things besides just plain regular Azure, but as well, I'm also an automator and a PowerShell enthusiast, and am the founder of the Norwegian PowerShell user group. So also in the working group for the Cloud Native Computing Foundation's project for GitOps. So doing a lot of things in those areas. I primarily work with Terraform, more or less every day. Most of my customers use Terraform, so getting a lot of good experience running things in Terraform. So that's why I'm here to talk about that. There's a couple of takeaways from this talk that I hope you'll bring with you into further on into the weekend. So we're going to talk a little bit about infrastructure as code and the benefits, but most of the time we're gonna spend talking about how Terraform works and how you can use Terraform to deploy to Azure. And hopefully I will pique your interest, and if you don't use Terraform today, hopefully you will in the near future. So I stole this title from the Pragmatic Programmer book, The Power of Plain Text. It's a really good book. Should read that if you're interested in those kind of things. I'm going to quote Sam Guggenheimer, which is he works for Microsoft. He's on the Azure DevOps team. He has written a lot about what DevOps is and the surrounding topics. So infrastructure as code is one of those. And he said that it's infrastructure as code is the management of infrastructure and in a descriptive model, using the same version as the DevOps team uses for source code. Like the principle that the same source code generates the same binary, the infrastructure as code model generates the same environment every time it's applied. Infrastructure as code is a key DevOps practice and is used in conjunction with continuous delivery. So what is infrastructure as code? Well, it is a way to define your infrastructure in plain text, really. Some of the benefits of this is that you'll have a source of truth. So since you have the code, that's your reference point to what's going on in your environment. It hinders environment drift and snowflakes. So snowflakes is when you got unique servers that take on their own life, and they're not they're not by standard. They have their own unique quirks. And environment drift is basically when things start living their own life and just continues on their own path, and then no one knows how they got there. But also the code can work as documentation. So instead of you doing all the work manually and writing a lot of documentation, you could refer to the code itself. So the code itself would be documentation for how your infrastructure looks. And this is all well and good, but without continuous integration and continuous delivery, it's just empty files there, and you're doing things manually, which is something we don't want. We are gonna do things manually today. There's not going to be any CI/CD demos, but I just want to mention this because this is key part of why we're doing infrastructure as code. Having continuous integration, continuous delivery set up means that we can set up what we call a GitOps workflow, where you have your infrastructure defined as code in a Git repository, for instance, or another source control environment. And when you update the code, a process kicks in and takes that code and then either changes or deletes or whatever it is you want to do. And this helps us get better code quality because we can set up automatic testing. So instead of doing things manually and hoping that everything will work out, we'll have automatic tests that can actually look at the results and say this is good or this is bad. We'll also have what's called linting or formatting. So if you have a certain code structure, like Terraform has a certain way, that's the best practice at how things look. By using linting and having it format automatically or check the formatting, we can stay adherent to those things. We also have change transparency. What I mean by that is everything will be logged and we'll get rapid feedback. So as soon as something happens in these pipelines, we'll actually know what's going on and have a better view of how things work out. This is tied into the automatic delivery. So, for instance, what we can do is we can have critical systems that might not be automatically deployed, but if it's trivial changes and stuff like that, we can set a test that checks those things and go like, yeah, okay, this is a normal change. We'll just allow it. And then as soon as you update the code, you update your infrastructure. So those things are good to know about infrastructure as code, but infrastructure as code can be a lot of things, and we have several candidates. But what we're going to talk about today is Terraform from HashiCorp. So why do we use Terraform? We use it for many reasons. It's open source, so the CLI tool Terraform, which you see here on the right, is available for you to download right now, and you can use. There's no catch. You can just use it. They have some things that are powered by their open source, but they make money on, like Terraform Cloud and Terraform Enterprise. If you want to run it in their way, in their pipelines, I guess you can call it. But the tool itself is open source, and if you use Azure DevOps, you can use Terraform in a pipeline there. There's nothing stopping you. Terraform is stateful. So that means that when you deploy things with Terraform, it will create a state. That state is a file that describes how things are at the moment. This is to enhance performance. This is also to enhance security and make sure that if something diverges from that state, which is set by Terraform, you can go back. HashiCorp has an entire page referring to talking about why they went for stateful and why they think that's the correct way to do things. Some of these aren't stateful, but Terraform is. Terraform is also declarative, which means that instead of saying that you want a certain virtual machine set up with a certain thing, etc., 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 you define how you want things to look. So you're just saying, I want a virtual machine, or I want a Kubernetes cluster, and it should look like this. And you don't really care about the process to get there. You just say, this is what I want, and Terraform does that for you. Terraform works on modules, so it's modular. By that, any Terraform code is defined as a module. If it's the Terraform code where you deploy things, that's your root module. That's where you start. But you can also take code and put them into other modules which you can call. on. So if you have a certain process, maybe a certain way that you define a virtual machine, you can put that code into a module, and then every time you need to deploy a virtual machine, you can refer to that, which means obviously that you'll create the code only once instead of doing it every time you want to set up a virtual machine, which saves time and it keeps things dry, as we call it. Don't repeat yourself. It's also masterless and agentless. So there's no server and there's no agent that needs to be installed on anything. Terraform works directly towards APIs, and you don't need to run it on a server. You could run it on a server. There's no real reason to, but if you have build servers and stuff like that, you could put a Terraform on there. But there's no like control point that controls how Terraform deploys things. You just run Terraform on your Terraform code, and then it works. Speaking of works, it's platform agnostic. So we're talking about Azure today, but you can use it for more or less every single cloud, private cloud, public cloud, anything in between. Not only clouds, it also works with backup solutions. It works with Kubernetes directly. It works with et cetera, et cetera, et cetera. More or less everything that you can deploy, that you can reach through an API, can be used Terraform for if someone created a provider. I'll come back to that later. And it's a binary created by in Go. So it's multi-platform. So it works on Mac, it works on Linux, it works on Windows. So that's why you want to use Terraform itself. So, but let's take a look at how it looks. I'll get to some practical demos in a little bit. So bear with me. So we have these building blocks, as I'd like to call it. We have certain pieces of code that's necessary for this to work. If we start at the top, we have providers. So like I said, providers is the way that we connect to a certain cloud or a certain service. So Azure has an Azure RM provider, which speaks to Azure Resource Management, the API, right? There's also an Azure AD. So when you're doing stuff towards Azure AD, you can use that provider and use the resources from that provider. There's so many providers that there's no reason to list them all, but basically, if you think of it, that it probably exists. As you can see here, we're using a little bit weird syntax. We have a Terraform block, which have a required providers. This is how they want things to look. So if you have several providers, you would have them listed here. And Azure the Azure RM is a little weird. So we have a extra provider block here, which defines an empty feature. I hope to get rid of this soon, but that's how it is right now. We have resources. Let's see if I can point on the screen here. So we have resource blocks here. That's basically how you define resources. You know, funny enough. In this case, you can see that we said we have a resource and we refer to the Azure RM resource group. So we're creating a resource group. Then we're giving it a name. This name is our reference point. So if we create several resource groups, we can reference to all of them inside of the Terraform code. This has nothing to do with the name of the resource group or anything like that. This is just for Terraform to keep track of what's what. And as you can see here, we have a name and location field where we set a variable deployment name and a variable location, which is defined above. Like I said, it has this name, so we can reference this. So if we go to the next resource, we'll see that we have we wanted the resource group name and location, and we get them from our resource group here. So we refer to the name of the resource or the resource Azure RM resource name, and then the name of this particular resource. And then that resource exports different kind of things. In this case, we know that it exports name and location. So we're basically just getting what name and what location this resource group has and using that in our code. So as you probably understand by now, you can then create things and refer to things and kind of just build your code in that way. And we, as you can see here, we have a data resource. I didn't jump over. Okay, so we have a data resource here. A data source is a field where you can go and get information about a certain topic. So in this case, we're again referring to the Azure RM resource group, but it's the data source, and we're setting a name. So if this resource group did exist, then that data source, I could refer to the name and location and everything from a resource group that aren't created in this Terraform file. Again, we're talking about variables. We have these variable set. We can define a type. We can also not define a type, but it's better to explicit define the types, because sometimes Terraform gets confused depending on what you're putting in, and defining a type probably helps you in the long run. But
Robert,
yes.
Sorry, there's a question here. If there's a possibility to make the example code a little bit bigger?
That's a really good question. This is inside of PowerPoint. I could probably do that, but in not that long, I'm going to jump out of this and I'm actually going to show the code, and then I can zoom in and
okay.
We'll go over this again just shortly.
Okay, great.
All right, so we have the data, the variable names, like I said, but right here we have a default field set, which means that if we didn't have this and we run the code, it will ask if we need to, put in a value here. But by defining a default one, if we don't do that, it will just use this. So this is just to safeguard that this code actually will work. We also have an output field, which when the Terraform execution is done, it will output a certain value. In this case, we're just referring to the ID of the resource group example, actually the data source version. And other than that, we have modules as well. I don't have that example code here because it gets kind of convoluted as soon as we start talking about that. So maybe we'll look at it if we have the time. Working with Azure, so you have several ways to do that. You have you could work from your local computer using Azure CLI. So you log into Azure and set the subscription that you want to work with, and then you start running Terraform commands towards it. You can also use managed service identities. So if you're running a build server in Azure DevOps, you can have Terraform installed there, and then you can use the managed service identity if you have that. Or you can set it up with service principals with either client certificate or client secret. So that's basically how it works. And I'm going to take a look now at some code. So let's see if we can get teams to work with me here. There. And let me know the text here if it's better or not.
Yeah, this is much better. Thank you.
All right. Yeah. So again, if this is even small, I can zoom in a little bit. But this is we have our folder structure here where we'll have right now we have two .tf files. One that's called main and one that's called variables. This is a pretty usual. It's a thing that you usually have. You can split up things when Terraform looks at when you run Terraform in a directory, it takes all the .tf files and just merges them, which means you're kind of open to define where you want to have things. So if you have several resources, you get a lot of text, then you could possibly have that in different files just to make it easy for yourself, which is what I usually do. But in this case, we have everything in one file, more or less, except the variables, input variables. So as we can see here, we have, or not at the top, we have our Terraform block. Very explicit, this git commit thingy, but we'll just walk around them. So we have the Terraform block, which has the required providers, which have the Azure RM set at a certain version. So this is the newest version, I think, unless something new has happened since yesterday. We have a provider block. So this is a thing that's kind of quirky with the Azure RM one. Usually you would just set your required providers here, and when you then initiate the directory to use with Terraform, it'll download everything, right? But in this case, the Azure RM provider has some old legacy things that are still stuck here, so you need to have an empty features block. I'm hoping they'll change this in the very near future. And that's what is necessary to get Terraform to work, really. So you're defining a provider which you're going to use, and then that's it. You can also define where you want your state to go. So the state by default lands in your working directory. But if you define a backend, for instance, Azure Storage, or well, you could work with Terraform Cloud. You can also have state there, or any other place. You can define that in your code, and that's where the state will be. That also, if you're working with others, that might be good, because then the state gets locked when you start running Terraform, right? So you don't have two people trying to do updates at the same time. Again, we have the resource block here with an Azure RM resource group. We are calling this for Terraform, just as a reference it to. And we're doing a little thing here. We're formatting our name using the format, the way of doing things here. You could do it in several ways. This is the way that I prefer to do it. So we have our what our name will be, which is a string, which is defined afterwards, a -rg. So that's why this is what happens is using the variable deploy name. We can look at the deploy name while we're at it. So this variable, which defaults to well, this long name, and puts a -rg after it, and on the network security group, it got a -nsg, etc., etc., etc. So same way of doing things across the board here. We're referring to a location, which again is set now to default to West Europe. It's default to West Europe, but that doesn't mean that I can't override it, right? Because, or else why, that would be weird. Then it would just be a static set thing. So I defaulted to West Europe, so I can just run Terraform plan on this and don't have to do anything. But if I wanted to, I could set this location to something else, right? There are different things that the different resources need, right? A resource group only need a name and location, but a network security group and a virtual network requires a lot of things. In this case, we're for the network security group, we just need where it should land, like literally the resource group and location. But for the virtual network, we have address spaces. This obviously could have been a variable as well, would probably be better. We're defining a subnet. We're actually defining two subnets. And as you can see here, we have a subnet that are just defined open, and we have a subnet that is defined with a security group. And again, here we're referring to the resource type and the resource name. And by looking through the documentation, you can find that it can export the ID. So what we're doing here is putting in the object ID of this resource group as the resource group for this subnet. And as well, we have on the virtual network, we have our tags, which is a variable. And this variable, I have not set a type which is against what I just said, but I've now set a type, but this is a map. This is a map type where we have a key and a value. So, you know, obviously that's how tags work. They have a key and a value. So this will be environment demo source Terraform. So we have our code, and that's cool, but the code doesn't do anything, right? It just sits there. So we open a terminal and we write a Terraform init, which is initiating the folder structure and looking at what dependencies do we have, what providers do we need, and what modules do we use. That will also get downloaded. So by doing that, it will find the Azure RMM provider, which matches this, the version that we said, installing it, aka downloading it. And it generates a log file, which just logs the dependencies. So if you change that, you need to init again and those kind of things. So that's just a mechanism to try to keep that flowing nicely. And we don't have a lot in this, right? So it went pretty quickly. But if we do if you look at the folder now, we got our provider set. It's a binary or .exe in this case. And obviously, if this was on a Mac or Linux, you know, you get a normal standard binary with no file extension. So yeah, if we do now a Terraform plan, it will look at the code and it will calculate dependencies. So if you have a certain resource that needs to be created first, if there's like a set path. So in this case, you need a resource group. You can't put a thing into a resource group unless you have the resource group. So it starts building the dependency graph in the background. And it gives you this nice little thing that says, so these are the things that's going to happen. We're going to create this security group. We're going to create the resource group. They might be a little weirdly placed in line here, but Terraform will know which one has to go first. It will create the resource group first. So don't think about that. And if we already, well, we can look at that afterwards. So as you can see, this doesn't exist. So everything is new here, everything's green. And we could define a file that we have this plan in, a plan file, which we then could use to make sure that when we're doing the change, this is what's going to change. If we have this in a pipeline scenario where things are automatic, you probably want to do that. So what you approve when you see it is the same as going to be executed, right? Because when I now do a Terraform apply, what it actually will do is do a Terraform plan again. So if anything has changed since last time I did a Terraform plan, and now that would happen, that will be what will be applied, right? So that's why you can do a Terraform plan, put it into a plan file, and then do a Terraform apply with that file, so you'll get the correct changes. But nothing has happened. We got the same result, right? Except now we can say yes, that this is what we want to do. And as soon as we do that, Terraform is going to kick off. Going to talk to the Azure API and start creating things. So you see it's created a resource group first. Did that in 1 second, didn't take long. Now it's doing the network security group because we want that before we create the virtual network. There it's done, and now we're going to do the virtual network itself.
There is a question here from someone named Thundercat.
Oh, cool.
Is it possible to test the Terraform script without publishing the resources and services? So to confirm it works, because the deployment of services can be a little bit time consuming.
Right. Yes. No, not really. Well, there are some testing tools that are out there, but they're probably going to take just as long as doing an apply, and obviously things can happen in between here, right? Things might stop working, but you can't really test. The Terraform plan itself does as much as anything else for testing if it will work. As soon as you run a Terraform apply, there might be problems with access and things like that, or you don't have the right permissions and things like that might trigger afterwards that Terraform couldn't see until it tried talking to the API. But there's no real way, as far as I know, that where you can take something and see for real what's going to happen when you start applying in that sense. It's good that you're doing the questions, because I can see the chat right now. So thank you. But as we can see, we got now our 3 resources created. And if we look into the file structure here, we now have a terraform.tf state. So if we close this and open that, you'll see a JSON formatted state file, which keeps track of all our things. And as you can see, it has dependencies. So this is the what is this? This is the security group. It has dependencies towards the resource group. So when we're going to delete this, they would know that the Azure resource group in itself is kind of the last step here, right? We know that when we go into the portal and delete a resource group, you just delete a resource group and everything else will, follow. It will be gone. But there's actually some dependencies happening there as well, and sometimes you can't really do some changes without removing some of these things. So Terraform keeps tabs on what are dependent on what. Obviously, it doesn't always work, and that's when you kind of have to do things manually and play around with the state. You shouldn't update the TF state file. There's own commands for doing that, but that's kind of advanced troubleshooting, so not something we're going to look at today. But now when we have the state, right? If I were to change something, let's see, let's say that this subnet here is supposed to be called Iceland. That's the entirety of Iceland there, right? So we're changing that. And if we now run a Terraform plan, instead of having everything displayed, it will see what is the difference here, right? So the difference in this case is that it can update the resource, virtual network resource, in place, which means it doesn't delete it. It updates the subnet block in place, right? But what it does is it's going to remove this one subnet, and it will add the other one. There's commands to get more verbose, so we'll see more. But this gives you the gist of what's going to happen if you do a Terraform plan. So if you do a Terraform apply, sorry. So if you do apply, and I'll use the auto approve flag. You shouldn't do that in production, by the way. It will do another Terraform plan and then just apply those changes. And again, this will be put into the state file, and everything's honky-dory, more or less. Right. Are there more questions in the chat now while we're just waiting? Probably get up the chat in the other window, right?
Yeah, there is. Can you confirm a /24 subnet would fit the entirety of Iceland? I am from Iceland.
Yes, I'm pretty sure. Well, I know only 250 people from Iceland, 250 something. So we're probably going to fit in there, right? No, it's just to have something to update. All right, well, we can just easily say Norway, but yeah. So if you're obviously if you're changing this address prefix, for instance, to something that doesn't fit into the address space implied in the virtual network, Terraform will let you know. It's hard to do mistakes this way because you'll get checked, right? This is also one of the better things about using infrastructure as code. You'll have a more I guess a better view of how things work and where you can change things.
There's another question here.
Yep.
Okay. I know there are different what you can say items or objects within the cloud environment, as you say RM for Azure. But is it possible to unify this so you can use one Terraform script for all cloud providers?
If you under required providers put in Google Cloud Platform or Azure or Amazon Web Services, or even OpenShift if you have your own cloud, etc., you can put all those providers in there. Terraform will then download the required binaries to work with them, and you'll refer to them inside here. So as you can see by the naming standards, the resource here is referring to an Azure RM resource group. This only exists inside the Azure RM provider. But if I were to deploy a service in, for instance, Azure and Google Cloud, I would just have to create two different resources referring to two different resources inside the providers. So you can make this as complex as you want or as straightforward as you want. There's nothing stopping you from using several providers. When I create Kubernetes clusters, for instance, I do use both the Azure RM to create the Azure Kubernetes service cluster. I use the Kubernetes cluster to do changes within the cluster when it's up. I also use Helm provider to deploy Helm charts into the cluster, and I can do that all within one file if I wanted to. Obviously, I'll space it out a little bit so I can remember where I am. Yes.
Thank you. There's no new questions, so just continue.
Right. Well, that's basically it. Obviously, this is a very, very basic look at how Terraform works, especially against Azure. We have a little time. We have 10 minutes? Sure. What I can do, I can jump into a Terraform module, but I don't need to stop sharing and open the right one. So just give me a couple seconds while I frantically click on stuff. Maybe not. Maybe do the correct thing. All right. And then I'll stop sharing, and I can now share it's that window, right? Yes. I'll move things. It doesn't work when it's not a big screen. All right. So here we have a module that I created for Azure Kubernetes service. I'm doing a lot of talks on these kind of things, so I have a pretty complex module here, but we're not going to use that many of the last couple minutes to talk about that. But here, as you can see, I'm referring to 3 different providers, for instance. But so here I have several things. I actually have a lot of things. Visual Studio Code likes to Terraform init everything that I work with, so it will say this for a little while. But we have our provider set. We have a lot of variable sets. So this is not a small thing. This has basically everything you need to create a Azure Kubernetes service cluster. But as you can see, we have the variables, we have the main file, we have our outputs, but then I separate the Azure Kubernetes cluster inside its own file because it's pretty massive, as you can see. with a lot of the more advanced things. So we're not going to take a look at now. The 27th of April, I'm going to be at Developer Week talking about this module. So if that's of interest, then there's that. Also, yeah, I have some free passes for Developer Week. I didn't think about that until now, but if anyone needs that or wants that, it's I think it's cost like 85 euros to get in, but I have some free passes, I think, still. So just let me know and I'll hook you up. But
there's one question here.
Yep.
Terraform and secrets. How do you store, for example, a VM password or any other sensitive information?
So that's an entire topic. We could probably talk about that for a long time, but Terraform recently came with a sensitive option for variables. So what you would do is probably in a pipeline scenario, you probably would set your sensitive secrets as variables there, right? And then refer it to a file or to a variable in Terraform, right? To get those things aligned. You can set most things that you need are well, for instance, for Azure, you might need a service principal and then client secret and all those kind of things. That can be set as environment variables. But if you're doing secrets inside of code, you would refer to something. So you could get code through Azure Key Vault, for instance. You can integrate this the Terraform code with the provider, Azure RM provider, and then get the secret through data source there. Or you could talk to HashiCorp Vault, or there's numerous ways to do this. Like I said, I could probably talk for 2 hours about that. But in essence, for things that makes this work, like the things that you need to work with Azure, you'll have it as environment variables, and everything other is through the logic of data sources and things like that. Yes, so we have this module which basically has many inputs, variable inputs, and based on those, I create a cluster, right? But I have an example here. So this is basically just a short version of my talk. This is all that's needed, right? We have a module block called Kubernetes. It can be called anything, and it refers to, this is publicly deployed, but this could be a Git address or a Git source or anything like that, HTTP as well. But this is deployed to the Terraform registry, so it's open and out in the public, and I just give it a name and what resource group I want it in, which I create in the code in the other TF file, and the subnet ID, because that's AKS need that, also created in the other file, and an admin group, which I read through a data source, and that's it. Well, in this case, it's also have a depends on here. That again, a different topic, but so this creates a cluster based on my predetermined settings, right? It gives me a one node pool with certain VM size set up in a certain way. But if I then want to do something else other than what's standard, I also have opened it to so I can define the entire cluster if I want to. So if you, for instance, with the Azure Kubernetes service, which is a big thing, you might want that code created once in a module. You don't want to do this every time you want a cluster, right? That would be overkill. So by moving that code into a module, you can create something that you can reuse. So that's how modules work. This is a child module that works with the parent module or root module. Yeah. So unless there's anything else.
There's no more questions. There are though people asking for tickets or passes.
Right.
Is there a way to contact you and even if people have more questions or if they want to get some help from you within their own environment, is it possible to get in contact with you?
Yeah, so basically I'm on Twitter, which everyone is. So even a direct message there would work. It's open. I'm also on LinkedIn, obviously, and most of the code that I do is open on GitHub. So if down in the left-hand corner there, you have all of those names and addresses. Other than that, obviously, I work for Crayon, and we are in Iceland, as probably many of you are aware. And obviously, if anyone needs any help from me, just talk to your local Crayon offices, and then they can get in touch with me.
Yeah, they can contact me also. So
yeah.
So I think this is very good. We are out of time, so if there is no more questions, then I just want to thank you for giving us the time for showing us this. It is really interesting, and I can see that this is very powerful tool. Maybe one question from me: the difference between this and Project Bicep, if you know that.
Yeah. So Project Bicep is it's a language that they kind of created because the Azure RM or the ARM templates are so hard to understand because they're very machine read. So Project Bicep is just trying actually to kind of do what Terraform is doing, which is creating a human readable code that would make sense, right? So there's not a lot of difference, to be honest. But Bicep is not well. It's pretty new, right? Terraform has been around for a while. It's still not in version 1.0, but it will be soon. HashiCorp works towards releasing the 1.0 version of Terraform, but Terraform is widely adopted. It's more or less that and Ansible are the two tools that people that do DevOps want to use, more or less. And also there's a lot of resources on it and all those kind of things. But it's also, like I said, it's platform agnostic. So if you learn this to work towards Azure, you can also then work towards Kubernetes or even different cloud providers and different tools. There are a lot of providers out there for a lot of things. So that means you have one way of working with a lot of things, not just Azure.
Yeah, I think the most difference between Bicep and Terraform is that Bicep is more focused on Azure, and Terraform, of course, is you can use multiple cloud providers. So that's the good thing. And of course, as you said, they've been very long doing this for a long time. So their system is more evolved.
Yeah. And there's so many people using it for so many things, which obviously then goes back into Terraform as a tool, not just Azure.
Exactly. One more question. The pricing. Do you know something about that? What kind of pricing solutions do they have?
So Terraform, the what they call Terraform open source or just Terraform CLI, that's totally free. There's no cost. You can go download the binary and start using it now. There's no cost at all. Then you have the enterprise and cloud. So enterprise is for running things locally, and obviously cloud is a cloud platform. That has a cost, but just for basic use, that's also free. So you can go to, I think it's app.terraform.io and register and start deploying things through their pipelines for free. Pricing is pretty good otherwise. Obviously, you get some support things. And I probably should know more since Crayon is actually our HashiCorp partner, but that hasn't been fully set all the details yet. But if you need to run Terraform Cloud code or Terraform code, and you want to use a tool that's designed for that specific use, to have easy to get going, Terraform Cloud is a pretty cool way to do that. I work with that daily. It's pretty nifty.
Okay, so I think this is it, unless there's any other questions. If not, then just I will say thank you for this time you have given us. We have a lot of attendees now, so that's very good. So I will. Do you have the slides so I can share it with people?
Yeah, I can share it with you, and you can put it out wherever you want to put it out.
Okay, thank you.
Okay.
So thank you again, and hopefully we will see you again later.
Absolutely, we're great.
Okay, bye-bye.
All right, cheers, bye.
Okay.